For our last section on matrices, there are a few more functions that I'd like you to take a look at. So on this slide here, we already looked at the two at the bottom. We looked at the reshape and the diagonal functions. This allows you to change matrices around using reshape or create a matrix with specific elements in the diagonal. But the ones I want you to look at here are length and size. This is a good function to use when you want to know how long a matrix is, or what the rows and columns of a specific matrix are. For example, if we create an array X and we say it goes in increments of 4 up to 97, for instance, well, we could probably figure out how many numbers there are, but we can also ask length of X. This will give you how many elements in it in the longest direction. We could also ask for the size of X. The size function is not just going to give you the longest dimension, it's going to give you both. It's going to give you two answers, the number of rows and the number of columns. So the way that we've defined X, it should be one row, and we found out it was 25 units long, so there'd be 25 columns. So the result of size X would be 1 and 25. A few more that I'd like you to try. Many of these are to be used kind of at your own leisure when you want to. We won't use most of them in our class, but you might find them useful when working on your labs or your projects. So the first one, the mean function. The mean function will take essentially the arithmetic average of all of the elements of A. Or the sum, that will add all of the elements of A. The sort function will rearrange the elements. It's going to put them in ascending order from smallest to largest. The determinant function is for a matrix. That matrix must be square. The dot and cross product, if you've gotten into Calc 3 yet, you'll know very well about how to find the dot and cross product. So you need two vectors, vector A, vector B. And it is much easier to use MATLAB for dot and cross product than it is by hand. If you have a square matrix A, you can also use the inverse function, INV of A, or the rand function. We did look at rand already. This generates information for you, whereas all of the functions before rand on this slide give you information. And then finally, the colon. The colon does have a few different uses. You can use it by itself. You can use it to access all of the rows or all of the columns of a specific matrix. Or you can use it going from first to last, or first increment last. There are multiple uses. Now this is a good table for you all to take a look at. We've talked a little bit about when you need to add that period in there. Well, this is a description of what all of these things mean. So if you see a period, it essentially means element by element. So A period asterisk B. This is element by element multiplication. Same with the division sign, right and left division, or exponentiation with the caret. If you don't have that period, it's going to use normal matrix multiplication or matrix right or left division. Or if you want to find the transpose, you can either find the complex conjugate transpose or a matrix transpose using the period and the transpose sign. So here's what element-wise array operation does. Let's look at the left side first. We have one matrix, 1, 2, 3, 4, so it's a 2 by 2, and then it's multiplied by 1, 0, 0, 1. And notice that 1, 0, 0, 1 is an identity matrix. So the value, or the result, should be the same as the incoming matrix, which is just 1, 2, 3, 4. But what if instead of 2 by 2s, they were 1 by 4s? We rearrange their sizes a little bit. Well, a 1 by 4 times a 1 by 4, we can't do that. The dimensions don't work. The number of columns in row 1 does not match the number of rows in matrix 2. On the right side, we're going to use the period instead. How is this different? What is actually happening? Well, if we want the first element of the result, we're just going to multiply the first element of matrix 1, which is 1, and the first element of matrix 2, which is 1. In the second element, which would be below the 1, we're essentially multiplying the 3 by the 0. Or the third element, which is a 0, is taking the 2 times the 0. So play with it a little bit. I know it can sound a little bit confusing at first, but once you get the hang of when to use the period, what matrix operations are legal and illegal, it can become very, very useful for you. Okay, here's an example. So we're given an equation for y. And we say y is a function of x, and it's equal to this equation here. 2x squared minus x plus 4 all to the power of 3, and then divide that entire thing by 5. And we're going to say that the values of x are minus 2, minus 1.5, and it looks like there's a pattern here. It looks like we start at minus 2, and then every next number goes up by 0.5, all the way up to 2. So there's a trick that we can use here, one of the shortcuts that we learned. Let's try it. So we're going to say that x goes from minus 2. We use our colon. It goes up by 0.5. Use our colon again, and it ends at 2. Now, notice when we use this shortcut format, we don't need to put the square brackets on the outside. They're not necessary. You can, but you don't need them. I'll prove it to you. Either way, you get the same result. Okay? So now we've stored x in our workspace. All I've done is cleared the command window. And now we have this funky equation for y. So let's see if we can figure that out. So it's 2x squared minus x plus 4. Let's get that part first. 2x squared minus x plus 4. Now this entire thing is to the power of 3. And then that entire thing is divided by 5. Now I'm purposely going to get an error here. And I want to see if we can identify why. It doesn't work. Well, we just learned that because x is an array, we can't square x this way. We have to put a period here. So let's go back. Right after the x and before the operator, we're going to put a period. Let's see if that one works. It doesn't. Here's why. This entire thing is an array, which means we cannot put it to the power of 3 without a period right there as well. So we'll try one more time. There we go. Now, it can be a little bit tricky to identify exactly when you do and do not need a period, but just remember, if you're ever multiplying, dividing, or exponentiating arrays, which is a 1 by n or an n by 1, you must use the period.